In today's video, we will be talking about diverging lenses. After watching this video, you should be able to draw a ray diagram for a diverging lens and understand the image-object relationship for diverging lenses. So just like in lesson 6, we talked about ray diagrams for converging lenses, this is just the opposite, a diverging lens, and basically where will that image form from the object, and will that image be bigger or smaller, inverted, real, or virtual? All those are questions that can be answered by a ray diagram. And again, it's not a mathematical thing. Instead, it's just kind of this way to be able to kind of give a generalization of what the image will look like. Okay, so let's get right into the fun. These are the rules for drawing a ray diagram for a diverging lens. So first is you pick a point on top of the object and draw 3 incident rays traveling towards the lens. Okay? And like I mentioned in the previous videos, typically the object is almost always going to be an arrow. Even if they say like a candle or a can of soda or whatever the case may be, you can use an arrow to represent that object, and you just pick the top of the arrow. Okay? Once these incident rays strike the lens, refract them according to the 3 rules of refraction for double concave lenses. And I'm going to refresh our memories on those 3 rules in my example problem that I'll be working shortly. Okay, so I'm just going to follow the 3 rules that you guys that we talked about in the previous lesson. Then locate and mark the image of the top of the object, and then repeat the process for the bottom of the object. Now number 4, again I mentioned this in previous videos, is not really necessary to repeat the process for the bottom of the object. If it's an arrow, you can just basically draw in the arrow if you know where the top is. Okay, so it's pretty simple. Okay, let's do a practice problem here, and let's set one up here. We're dealing with a diverging lens. So first thing I'm drawing is I'm drawing my principal axis. And I'm going to draw a relatively large diverging lens just to kind of make things easy to see. And the very definition of a diverging lens is that it's thin in the middle and then fat at the tops. And I'm going to draw 2 focal points because each lens has 2 focal points, and they should be about equal distance. Not should be, they are equal distance from the lens. And so try my best to measure those out. The right side might be a little smaller than the left, but that's okay. And then I'm going to draw my object. Okay, so let's put my object here, and I'm going to make my object kind of large, just again to help with visibility. Okay, so the rules of ray diagrams for a divergent lens is you basically need to draw 3 incident rays. Okay, and the first incident ray is going to travel parallel to the principal axis. And then it is going to refract out of the lens in such a way that if you take a ruler, it would line up with this focal point. So if you can kind of use your imagination, there's going to be a line going through here, and it would refract out that way. Okay, so basically if I had a ruler, this line should lead back to this focal point right there. Okay, that's the first rule to drawing your incident ray for a diverging lens. Okay. The second rule, or the second ray that I'm going to draw and deals with the second rule, is I'm going to draw a line that if I took a ruler and I put it on the top of my arrow and I led it to this focal point, it would connect. Okay, and so I'm going to try my best to draw a line that goes towards that focal point. And I may have messed that up a little bit. As soon as it hits the lens, though, it doesn't make it to the focal point. As soon as it hits the lens, it is going to refract in such a way that it's actually parallel to the principal axis. Okay, parallel to the principal axis. And I'm sorry, my principal axis isn't a straight line right there. Okay, so that's the second one. The third ray is just going to, again, start from the top of the arrow, and it's going to go straight through the center of the lens, okay, through the center of the lens, and then onward through the other side. Okay, so I'm going to try to draw a line that's as straight as possible. So you go through the center of the lens and onward to the other side. Okay. Now right away you'll be like, well, where is my image forming? At least that's what I'm thinking in my head, because on this right hand side you'll notice all of these refracted light rays, none of them will intersect each other ever, right? I mean, if you keep drawing them out, they keep getting further and further from one another. And that's true. For any diverging lens, you will never have what's called a real image, an image formed on this side. They're always going to be virtual, which means they're going to form on the same side as the object. Okay? So how do I know where the image formed? Well, just like in converging lenses, if you have an object from the focal point to the lens, we had a virtual image. Okay? And the same thing's going to be true for this guy right here. So let me pick a color that will show up well. So I'm going to have to do something called drawing my ray tracebacks. Okay, and basically what that is I'm going to take this ray that goes this way, and I'm going to extend the line backwards. I'm going to represent that by dashed or dotted lines, your choice. And that's kind of the direction that ray traces back. You can see this isn't a very straight line because it really should trace back to the focal point. Okay. This one, it's going parallel to the principal axis, so I'm going to trace it backwards. And it would lead like there. Okay. And this one I don't need to trace back because it just keeps going. Okay. Where do all three of these rays of light meet? Right here. And that's going to be the top of my arrow, and that's going to be where my image forms actually. And you'll notice this arrow is much, much tinier than this arrow, and that's actually true for all diverging lenses. The images that are created are shrunk or tinier. Okay, and so this would be an example on how to draw a ray diagram for a diverging lens, and we will do a lot of these in class, but this is just one I wanted to show you on a video. Okay, so let's put some things into words for you to have in your notes. Images of diverging lenses are always located on the object side of the lens. Okay, they always will be on the left or on the same side as the object. Okay, they'll never be on the opposite side, always on the same. And so since they are always on the same, you're always going to have what's called a virtual image. Okay, the image will also always be upright. It'll never be upside down. And the image will always be reduced in size, meaning that it's smaller than the object. And this will be true of all diverging lenses. So what's kind of cool about knowing these rules is if you're drawing ray diagrams and you're not following these rules, you probably messed up somehow, and you should redo the problem is what my suggestion would be. Okay? So that takes care of today's video. I will see you guys next time.